Okay, why you need to learn assembly language program? This is the very, very basic programming throughout all others programming like Java, Python, C programming. So the very basic is the assembly language. So that's why you need to learn assembly language first before other subject on the programming language. So there is objective. You can read it. Why you need to learn all of the assembly language. And then what we're going to look into in this module 3 is on the introduction. And then we're going to learn the basic elements under assembly language. What is inside about integer, maybe constant, uh, character, all of that you need to understand. And then we look into the example addition and subtracting integer. This one you're going to were given with the template. So that template later on you will use for your programming. And then defining data, symbolic constant, and lastly your summarization. So of course summarization not going to go through all because it's basically what we have learned from 3.1 until 3.5. So assembly language. This is the oldest programming language. Sorry, I need to speed up. I think altogether 70 pages. So I need to finish it by today because if not, we're going to be very far away from other section. So this assembly language is the oldest programming language, and all of the language it is built to the closest reassembly to native machine language. So on your computer, of course, your computer will not understand what you said in terms of wording. Maybe you key in paragraphs, sentences. So your computer only will understand on the computer language, and this is the language that you're going to look, which is assembly language. So machine language is a numeric language specifically understood by your computer. So it is the closest to the assembly to the your machine language. And then you can see that your assembly language provide direct access to computer hardware, requires us to understand much about your computer architecture and operating system. So assembly language instruct a corresponding to a single machine language instruction. Of course, you have maybe long of your source code using your assembly language. But throughout all your long assembly language program, what you can see is later on you will summarize to be a single instruction. You instruction to your computer. Like we're going to learn the basic element. What is basic elements that available in our assembly language? There will be the integer constant, real number constant. It will be different, okay? Integer and real number, it will be different. Later on, you will see what is basically it. Character and string. Character and string also different. Reserve word. What is word that you cannot use in your programming? It always already reserved for certain action, like maybe move, add, subtract. So that is all the reserved word. So you cannot use in identifier, because identifier basically you can just use your own name. name. You can just write by your own name. Later on, we will see it. Directive, instruction, operand, comment. So if you write a programming, of course, you can put a comment to it. Maybe you just want to type uh, by me. So you want every others people that use your programming, your source code to know, okay, you are the one that created it. But if you just typing it without a command standard, so your programming will read it as your source code. So of course it's going to be error because it's not know basically what is by me. So that's why you will learn how you're going to write the command in your programming. And lastly, a register. Okay, under basic elements, this one you can read it under the introduction. So you have integer constant. First of all, you have integer constant. Wait. Okay, you have integer constant. This is how you're going to the standard for you to use integer constant. You will have plus, minus, and your digits. One, two, three until maybe infinity, and your radix, your basic of your numbering system. Let's say you have positive 7 to 3 decimal. So this is your radix. This is, or maybe decimal like this. Sorry. The decimal is T. Uh, oh, this is alternate. Sorry. This one is T. So hexadecimal is H. Maybe you have negative A1 hexadecimal. So this is radix. This is the digits. This is the positive or negative. So this is the standard for you to write in your programming under integer constant. So you need to memorize uh, the short form, the short form for the radix. So radix can be uppercase and lowercase. It doesn't matter. You can put AH. A is hexadecimal. This is the hexadecimal. You can also type AH. Or maybe you have 10 to the power of decimal. You can have this or you have this. Either one can because it doesn't matter on whether it is uppercase or lowercase. So that's about Reddit. And all the units, you need to memorize it. How you going to represent the binary? How you going to represent this decimal, octal, and hexadecimal? Please, I don't want to explain more on all this numbering system because this is already learned in several time in your chapter 2 also, and your digitalogy, and I already give you the videos related to numbering system. If no radic is given, this is very important because by default, if let's say it is not right anything like this one, maybe you were given only 7. Oh, 197. Positive or negative, it's okay. But I just want to show about the radix. If there is no radix given, you need to assume it to be decimal. So it will be base 10. So like this. This is the example that you can use. And it is assumed to be decimal. Wait. I need to pick a call. Hello? Boleh letak je dekat depan rumah. Ya, betul. Boleh. I dah unmute ke belum? Okay dah. So over here you can see that if that's the important key. If there is no radix number or units, you need to assume it as a decimal value. So this one is 26 decimal. This is 11010011 binary. This is the octal. This is also octal, which is you can use Q and also 0. Same, you can see over here. And this is the hexadecimal. A equal to what? 10, isn't it? So if you have 1A hexadecimal, you can see that this is 8 the power of 0. So this one is at the power of 1. We have decimal, hexadecimal. After hexadecimal, okay. You have, let's say over here, 1 times 8 and then plus A times 1. A in hexadecimal, it will be 10. So hexadecimal, you're going to get 18 in decimal or base 10 for 1A hexa. Isn't it correct or not? You can just convert it using your scientific calculator. This one also, this is the hexadecimal constant beginning with a letter uh, of 0 to prevent the assembler from interpreting it as an integer. Why? Okay. So let's say you have EH. I forgot E apa. B lah B. B H in your decimal is going to be 11. 11 base 10 or decimal. So this one, you can write this. People will understand. But your computer will assume it as B. Not as a BH. Not as a B hexadecimal. So if you want to represent hexadecimal but in front of it is a character which is not a number, so you going to uh see that you need to put 0. You need to put 0 in front. So I repeat again, if let's say you have B3H, you cannot just leave it like this because your computer will assume it as B3H, B3H, not a B3 hexadecimal. So if you have something that in front is the letter with not a letter, constant ABC. A until Z. So if it is in front of this, you need to put a value of a letter, then with a zero. So you will put the zero in front. If it is start with a letter, you must lead with a zero in front of it to prevent the assembly from interpreting it as an integer. So you can see over here, if you have one, it's okay because you lead it with a digit or integer. But if you lead with a letter A until Z, so you cannot use it. But I guess for hexadecimal, you are until F only, right? I forgot 15. 15 for your hexadecimal. Oh, hexadecimal best. Oh, sorry. 1A. No one is correcting me. 1A is 16. 16 to the power of 0 is 1. 16 to the power of 1 is 16. So 16 plus 1. It will be 17. I asked you to convert it using your scientific calculator also you didn't do. So you will convert it into decimal, you will get 17 decimal or base 10. So over here you will be until F only, I guess. If you still remember your hexadecimal numbering system.
Ma'am,
Yes.
the 1A, 1 is 16, but A is still 10, so it would be
Eh,
26.
ha. See, I forgot also. So it will be 26.
Yes.
Okay, thank you for correcting me. Just now you all didn't do it right. See, you need to do it, then you understand what is happening. So if I'm wrong, because sometimes I also forgot. So I thought hexadecimal is base 8, but octal is base 8. Hexadecimal is base 16. Base 16 it will be 16 plus A is 10. So you have 1 until 9. If you are reached to 10, it's going to be A. Until 15 is going to be F, isn't it? Hmm. So it will be continuous. So that's on the integer constant. How you can represent, how you cannot represent. So if let's say like this, you cannot represent it in the letter. So you need to put zero in front. So next is for your real number constant. So for real number constant, you can see over here, it is for you to represent as a decimal real or encoded hexadecimal real. A decimal real constant or option sign followed by integer. So this is the standard form. I don't want to read it. You can read it if I just read the slide. So it's easy for me to teach. So over here, this is the standard form for real number constant. It's slightly different. You can see you still have a sign in front, whether it is positive or negative. And then after that, if you see, previously you have digit. See over here, digit is basically nombor bulat or julat, which is no floating point. But for integer, you can see over here, you have integer with representing of the whether you have the floating point or not. So you can see over here. And then after that, you have the exponent, integer exponents. So this is the sign and also exponent. You can see sign plus minus and your exponent. You have also plus minus and then integer. So you can see over here how you represent your sign for your integer number and how you're going to represent the sign for your exponent. So if your exponent, you need to put exponent plus or minus and then the value of your integer. Example, valid for real number constant. This one is correct. You can use it. And this also can be used. This one is your integer exponent, which is 0. You can see also you have integer of 3 with a positive sign. And this one, your integer exponent is 0. This is your integer with the negative value. And this is the integer exponent. Over here also you have integer positive, and this is the integer and exponent. So this is how you represent your real number constant. Next, you have what elements? You're going to have also the character and string constant. So character and string constant. Character is single. Character is single. Which is you can represent it with enclosed single or double quotation. Uh, and you can see it's look like this. Single character only. While for string, you can have a sequence of character. So you have A, B, C. This one also can be as a string, but it's depend on you. Basically, this one can be a string. This is also can be a character. When you want to declare it, let's say you declare it as a string, so it will be a string. If you declare it as a character, it will be a character, but both can. You can see it's a sequence of character including space. So there is a space over here. This one is also there is a space, so it includes the space as a character. So enclose, whether you can use a single or double quotes. So like this, single, and this is double. So now you can see what is the difference between character, what is the difference between a string. So you have the ASCII character 1 byte for the ASCII character. Each character occupy a single byte. This is a single byte because this is a 1 byte of your ASCII character. And this is embedded codes are permitted when used in the manner of this one. So you can also have an embedded codes. Basically, it's similar to quite similar with your string constant, but it is more on the embedded codes, which is you write something and there is what a single and also double in between of it. And this one also embedded coded example of it. You have a single outside and you have the double inside of it. So that is between character and string. And you also already look into differentiation between real number constant and integer constant. So I guess it's very easy for you to differentiate it. You need to understand and memorize it. If you just go through one times like in my class only, then it's hard for you to answer. And if I check your test 1 marks, I feel like why you cannot answer, because we already discussed it many times in class. We do it extra class. Still, you cannot answer it. It feels sad also, but yeah, what to do, it is depend on you. If you think that you want to score, then you need to learn it, do it. Don't just read. If you just read without doing anything, which is you sketch in the piece of paper, then you cannot understand it. You maybe you can say, okay, okay, this one is easy, okay, I read it, okay, I already understand. But when you did not apply it, then it's very hard for you, because the question, which is your test, you need to apply. Although maybe you understand, but when you never try, you didn't try to apply it in a question, so you cannot apply it also in your test. So now you can see the next is under a reserve word. What words that you cannot just simply use it in different, let's say you want to put in your string, string constant, or maybe you want to put in your quotations, quotes. So that's all you cannot use. Wait, Malaysia. Okay, so you can see over here what word you cannot use, which is first, instruction mnemonics. Under instruction mnemonics like move, add, multiples, you cannot use as the identifier, because identifier, later on you will see, identifier is a program chosen name. You are the one that choose. I can put my name, even my name, as a identifier. So this is my identifier. Let's say I identify Lisa is equal to 179. So I just want you, which is my computer, know if Lisa then is equal to 197. Or maybe I put uh UTM 0 is equal to ABC. So I just give example. So this UTM 0 is identifier, which is I'm the one who want to identify. If this name, it will be like this. So I cannot use this identifier using move, add, or MUL. Let's say I put move equal to 197. So it's not going to be correct. It's going to be error, because computer know move is move, not identifier, something like that. Okay.
Ma'am,
So
I have a question. Is the reserve word case sensitive or not?
this one, reserve word.
Yes.
No, I think because you can also use MOV for your programming. If you look here, normally you have this one, M or V, for your what programming. It is a small letter normally in your programming. So for other, like in the comment, you can put it whether it's capital or small. It doesn't matter. But for the commands, of course, you need to follow exactly. Uh, let's say move, the command need to be in small, then you need to follow it. If let's say for positive negative, you need to put it like that, then you need to follow it. This one is just a reserve word on the pneumatic. Okay, so include also, you can see in your programming you have in, where is it, example. Okay, so you have the I includes. Sometimes you can try by yourself, because this is template. This template you can copy paste. You can see over here. You can copy paste because this is the template for you to later on edit it. If you put it into your programming here, let's say I put so you can see it's already inside it. To review. So there is no error, means that I can change my include whether I want to put it capital letter or I want to put it small letter also can. Maybe I try this MOV. So you can see if I put it as MOV whether it is have error or not. Okay, I try. So there is no error when I try to do it. Maybe I can start parts. So it's no error when I change it. So means that nothing basically happen whether it is small or capital letter. So for the cases, maybe you can try also to do others. Where is it? Okay, under pneumatic, you can see, and I already tried also in the include, there is no different whether it is capital letter or a small letter. Okay. So there is also operands, predefined symbols, and type attributes. You cannot use it as identifier. Okay. Now you look into your identifier. What is your identifier? It's a programmer chooser name. It might identify variable, a constant, or procedure, or a code label. So what that you can use, because you cannot use all of these 1, 2, 3, 4, 5. You cannot use this. So in identifier, what you can use? So you can use the character of 1 until 249 47. So let's say I use UTM 248. So it already more than my include digits. Is it correct or not? You can try it using your Visual Studio. And then not case sensitive by default. You can put the UTM to, okay, you can put UTM small letter and capital letter. Maybe I put 01. And not case sensitive means that it's similar to UTM small letter 01. And first character must be a letter. So in front of it, you cannot put like maybe you put 10 UTM. Cannot. Because first character must be a letter. You can see last time you cannot put this letter in front. You need to put 0 for the hexadecimal representing number. But now for the identifier, you cannot use number in front. So you need to put the letter in front. Subsequent character may be also a digit. You can have UT01M. So in the middle, you can also have a digit. An identifier cannot be the same as the assembler reserved word, which is these 5. Okay, that's it on the identifier. So it's not very hard for you to remember as long as you frequently try to play around with the source code, then it's easy for you to remember. Next, uh, symbol. Okay, this one is still under your identifier. You have the symbols of uh, the symbol is used extensively by the assembler as a prefix. So prefix symbols. So avoid using it as identifier. So if you can see that if you have the prefix symbols, so you cannot use in the as identifier. So please avoid it and make identifier name description and easy to understand. Just use a simple name. Maybe you define it as data 1, data 2, data 3. So it's easy for you to memorize it and recognize it. Same goes to your computer. So example of valid identifiers, var1, main, my files count. So as mentioned, it doesn't matter for you to use a capital letter or a small letter. And you cannot start it with the digit, but you can see you are using a character. This one is still under a character, which is ASCII character. This is all the ASCII character. Uh, so you still can use it. Although you can see, oh, this one is the digit. Or this one is not a digit in front, but this is the one that in front of it. Next is under directive. So you can see over here that a directive is a command embedded in the source code that is recognized and aid upon the assembler by the assembler. So not execute at runtime. So can define variable macros and also produce not cache sensitive. It recognize data, dot data and data as equivalent. So you can see normally it is not cache sensitive for small letter and capital letter. Although in between you have D A T A. It's similar to D A T A. Similar also to D A T A. So all together, if you have possibilities of 4 to the power of n, which is you can play around with positive capital letter, small letter. So it's all equivalent. So different assembler have different directive. So later on you will see what is directive. The source code that you are putting. Let me scroll down. So if you look into your programming, you can see this is your directive dot c dot data dot code. So this is one of example of for your directive dot data dot code and go back. Example to show the difference between directive and instruction. Okay, so you can see over here, this one, the words. If you still don't know, this is a double word. Word, okay, one word equal to uh 2 byte. One byte equal to 4 bits, 8 bits. So this, please remember this and look back what is all this. So if you have double word, you have 4 bytes. So this is important for you later on because you're going to apply your data. Let's say you have this one. You want to save it into your register or your storage. Storage, of course, your register inside it. So this one, this is your register, EAX. I forgot what EAX. There is a data register. There is let me check it. Where? Because it is not mentioned in your notes, but this is the knowledge that you need to know. EAX. There is also several other register. If you look into your your Visual Studio, when you run, you can see there is several register. A mean accumulator. Later on, you will see there is also EBX. B represent as the best register. And then you're going to have CX. C for your count register. C for your count register. And then you have another one is D. D for your data register. So this is all type of register. Later on, you will see when you play around with your Visual Studio. And you're going to have like actuator high, actuator low, base high, base low, counter high, counter low. Okay, this one under directive. Okay, now you can see over here. Executes at the running time, copy the content. Okay, first of all, for this command, you can see my var your that your names that you want to put any name is the word, means that you justify the space, how many space that are occupied for this my var, which is for double word it is 4 byte, is 26. This 26 is in decimal. So you need to convert it into hexadecimal. So the word directive. The word is a directive. And you can see after you have directive, this is the directive, which is a command embedded for your source code. And you can see after you have assigned, let's say you have my var. Inside your my var, you have 26 decimal. And second, you have move. Move is instruction. Move my var into your EAX. Terbalik kan? It's quite like a twist. Sepatutnya if you read move this one to this one. But in programming, you will read like this. Move this my var into your register EAX. So you can see, copy the content of your my var to your EAX register. So now, if you will ask, what is the value of EAX after you execute this command? So EAX register will have the value of 26 decimal because you move the value of your MyVar into your EAX. So this one is directive. Directive is the one that you going to assign uh how many space for you to have for your MyVar. So example again, okay, this one is under your directive on instruction. After this, you're going to see also another example after you look into instruction. So instruction is executable statement when a program is assembled. So instruction are translated by assembler into machine language bytes, which are loaded and executed by the CPU at runtime. So you're going to have label. This one is optional. Whether sometimes you can have a label, sometimes you no need to have also can because it's just optional. But you are required to have the instruction nominates like move, add. This is the instruction nominate, right? Another one is usually require, which is your operands. But sometimes usually you will use it. And another one is command, which is optional. You can see over here, you have you have the instruction nominates. This one. And you have the commands. See? This is the command. This is how you used to put command. So after command, this one computer will not read. You just put it for your understanding after you do the coding. Let's say you want to share with your friend, then your friend will see, okay, this one is to for move instruction. But computer will not read and execute it. So this one, okay, this one is under label. Under label, we see it one by one. What is label? So a label is identifier to act as the place mark for instruction and data. So you can see follow identifier rules. So data labels identify the locations of the variables. Example, define a variable named count. So you want to define a variable named count. So you define this variable count. And then after that, this one is your, this is not your instruction. So you have another one, code level. So this is data level. You have two types, data level and code level. So under data level, you need to identify the location of your variables. Uh, this is define a variable name as a count. So this is the variable that you want to define inside your count. But for your count level, use a target of jumping and looping. So this is the example. Example that instruction that end with a colon character. So you can see target equal to, okay, this is all the code label. Example, JMP jump instruction, target control to the label target, create a loop. So this example target, and then you're going to go to the move this. Or another thing is jump to the target. Okay, that is under labels. Now under instruction minutes, this one you already look, but you can see also you have move, add, sub, multiple, jump, and call. So it is a short word that identify the operation carried out by instruction. So if MOV is move, assign one value to another. If add two value. Subtract one value from another. MUL multiply two value. JMP jump to a new location. Call a procedure. So you need to memorize all of this. It is not too hard for you because normally it quite similar to the instruction. What is the task? MOV, of course, is going to be move. ADD is going to add. SUB, it is subtract, and so on. And another one is under operand. So operand is assembly language instruct can have between 0 and 3 operands depending on the type of instructions. So you can see over here, you have 1, 2, 3 operands. Okay, I show you. Okay, later on we will go back to that. Okay, you can see you have constant expression also is an operand. This one is one only. Register also can be as a operand. So you can see you have EAX, EBX, EX, EH. If you don't know this one, also you will like lost. What EAX? EAX is a register for accumulator register. EBX is for base register. AX. What EAX? Accumulator register also. Uh, and but it is for primary accumulator. This one is high for your accumulator also. High accumulator high. And then after this, you're going to look into low and so on. This is all type of register. And then memory, which is data levels, you have like example as account. So we look into example. How you going to write example or assembly language instructions having various number of operands. So you can see over here you have STD, INCEAX. You can see one operand only. Move, which is count EBX, two operand, one operand, two operands, which is you move EBX to your count. This one is you include your EAX, which is your register, and STD is set carry flag. There is no operand. As mentioned, go back over here. For instruction, you can have operand or maybe you cannot also can because it's usually have the operand, but it is not required. That's why you can have no operand. You can also have one operand and the maximum you can have 3 operand. This is the maximum and the minimum is 0 for instruction. So next is, okay, this one is already example under instruction. Now you have the comments. So you can have the comment. Typically, why you need to have a comment? Of course, you want to describe what that's the functions for each of line. Who is the writer? Maybe also you want to put the date after you did a modification. So you want to put, okay, this date I put. After that, when you revise it again, you update the date. So that's why you need a command. Technical notes about the programs and etc. So you have two ways to write a command. First, using single line. This one that you normally see previously, right? So you can see. Okay, this is all the command after that. Just for you to inform what is basically happened here. So this is how you're going to put commands for each line using semicolon, single line. But maybe you want to type in long sentences. So you can use the block or multi-line. So how you're going to put is you type command. After that, you start with the uh begin with the directive and any of program choose the character. So you can see it start and also end with this one. Uh, any of programmer chosen character. This line is a comma one, this line is comma two. You can have a long until you finish it with another. Uh, in Malay is tanda seru. So any question until that? I think this is more on theory for you to understand. So please go through it and see, apply it in a source code for you to see basically what is directive, what is identifier, what is reserve word. Later on you will understand it clearly because if you don't have the basic theory, you cannot write a commands or a coding, a programming. So what is register? Register a high speed storage location. So anything you want to store, you're going to store into your register. But there is also a few type of register because you need to store in a specific directory, right? So it is inside CPU designed to access as much higher speed than conventional memory. So this one you can see you have the accumulator high, accumulator low, 8 bits, 8 bit, and you have 16 bits for AX accumulator register. Ni accumulator high, this one accumulator low, this one is accumulator register. This is for your register for EAX. What is the name? But this is in term of 32 bits. So this is how basically your register look like. And you can see under 32 bits, under 16 bits, what type of register. And you will know that A is accumulator, B is base, C is carry. Wait, ada kelas. Kenapa? Kejap, kejap. Hari tu dah suruh Eri dah. Mak kan biasa bayar kan. Tapi mak bayarkan untuk budak-budak tu lah tapi tak ada Raisa. So cakap kat Eri masukkan Raisa. Hmm. Dapat abak. Dah kelas ni. Bye. Hmm. Okay, sorry. So you can see A is accumulator, B for your base, C for your character, C for your count, D for your data. So this is all register only in term of how many bits. 32 bits, 16 bits, 8 bits, 8 bits for high and bit for low. And that is under your elements for your assembly language. Now we're going to jump into our next, which is on our program template. Is it okay or not? Is there any question? As as mentioned, I need to speed up a bit. So if let's say you like, okay, I want to understand it more, watch my video later on after this. But if you want to know, you want to ask me question, you can just interrupt me when I try to explain. Okay. So this one is example additions and subtracting integer. So you can see over here, you have the program template. This is a template for you to do all your programming later on. Okay, this one. So you can just copy paste the template. Okay, this one. And you can put it into your Visual Studio. You must install it and you must try it, because your lab one, you need to submit your video and so on using your Visual Studio. If you still didn't install, normally you're going to also face the problem later on, because last time there is also a lot of perdana student having a problem. There is an error in just doing the setting up for your Visual Studio. So you already week 5. Huh. I already asked you to install it from week early of week, right? So please try to install it. So later on you can see, okay, this is the one, the very basic. So if let's say I want to play around with code, I will put it inside here, inside all the executive
Um,
instruction. Yes.
Doctor,
Hmm.
can you show us how to open it? Like, I'm a bit confused with the 2019 because the video that you sent is for 2010. So
Okay, I
I'm
close
not
it.
sure.
Okay, first time when I try to open, I think I already share also uh where is it? Where? I check. This one. Under your lab one Visual Studio, I already share with all of you how to open, I guess. Because we are also discussing some of the student having a problem. So please check it also in this video, lab one. So now I'm going to show you how I'm going to open. Okay, let's say I open my Visual Studio. So you can see that you need to select this one, open project or solution. When I open, I click it. So it's going to try to find where is the ASM template. This template. Okay, this template. So you need to save it. Like mine, I save mine is in here. Software, template, because this folder you will download from your e-learning, right? So you will see like lab1.sln. Your name, I guess. Let me check over here. Software. Alamak, this is under zip. So it is here. So you download this, and please make sure you install everything. Your R, WinZip, all, and also your Visual Studio in C, local DC. Don't install in different local disk. If you install in different local disk, you're going to get error also. So Irene, also you need to install in your local DC. So in your template, this one, you need to put it in your local DC, and you will find out there is I forgot the name basically, but please find the .sln. So when you open, so it's going to be look like this. So if let's say you try your first programming and there is error, please make sure you look into this extension. Sorry, tools. Get tools and features. I repeat again. Go to your tools. Get tool and features, and look. Okay, and look over here. Okay, it's loading. What you need to have? You need to have this net desktop development. This should be right tick. Okay, this one you need to install. If let's say it is untick, what you need to do is you just tick it, and then it will require you how many space for you to install. You just click install it, And then I also did this because I use Unity also. And another one more thing beside this one, you need to check your where is this? Window 10 SDK. For me, I use Window 10. That's why I need to install also Window 10. So this one, while you play around, again, I open it. I go to the tools, get tool features, and over here, it will show you the package, what you want to install and what maybe you already installed. So over here, I click this this desktop, and then under desktop develop also, and uh, I use Unity because for my works. And from here, you maybe can find individual component. It is a virtual Windows 10 SDK. Sometimes there is a 10, 9 point something. Pick the highest version. Maybe you can also check inside here. There is maybe listed the Windows Studio under your desktop development with C. So you can see optional. So this one you need to install it manually. So under this there is a Windows 10 SDK. Okay, so that is the one that you need to install. So you have several others, but pick the latest one. So that is the first thing that you need to do. Later on, if you still have error, maybe you did not install it in C. So please try to do it in C. And another one is under that things, which is tool, get tools, and then you need to check your package. Sorry, I think there is another one which is under SSH. I forgot. But if you have error, maybe you can share into our group, and I will also try to find out what is the error, because basically there is no error for the source code that given, only when you need to do the first setting. After the first setting correct, everything will be okay. Okay, go back to our slide. Okay, this is our first basic template. So we will learn it first before we go to our Visual Studio. So over here you have of course, your library. If you did not install your iwin32.inc, so you cannot run also because it's not find the library. And then you have .data. Over here you will insert all the variables, whatever variables that you are using for your source code. And code, your main programming, which is you insert all your executable instruction here. And if let's say this is optional, whether you want to display your value in the register or not, and then exit. Okay, this one is your main exits, and then end mains. So if let's say you didn't have this also can, but if you want to see it in your Visual Studio, later on you will see that you have the options for you to, okay, for you to look into this step of sorry, wait. Why I cannot stop? Okay, for you to see the register value. So you can see under debug window, there is a register. So over here, it show you the value. If you want to put, then you need to use the command call dump. So call dump register, you're going to put the value inside your register. Next. Okay, this one is under adding and subtracting example. You have a register are used to hold intermediate data and we call a library subroutine to display the content. Okay, next is over here. This one is the programming for you to add. And if you look into this, you know it is a 32-bit integers. If you didn't have this, it is 16-bit, isn't it? So if you have AH or AL, you have 8-bit. So everything over here have a meaning. If EAX is going to be additions or subtracting 32 bits. So first, you can see what happened. Move this value, this is 10000 hexadecimal into your EAX. Then after that, you're going to add. So now your EAX is 10000H. After that, add 40,000 H to your EAX. Ditambahlah 40,000 H. Now your EAX already 50,000 hexadecimal because you add. Then you subtract your EAX with this value. So your end of your EAX value will be 30,000 hexadecimal. Okay, check. First, you have EAX. Okay, this is the initial value. Depend on your program. Maybe before this, there is nothing. So it is starting from here. Then after that, you're going to move. So you move this value into your EAX. See, you can see 1, 2, 3, 4. So you have 4 bytes. 4 byte equal to 32 bits. Nak kena kira pula sekejap 1 byte equal to 8 bits. 4 bytes, you have 32 bits. Although you can see you only have this value, you cannot just write 10000H because this one is only, this 2 is 1 byte. This tak cukup lagi. Sorry. 1, 2, 3, 4, 5. 1, 2, 3, 4. 10000H. 1 byte. Ya Allah Akbar. Okay, I show it here. This is 1 byte. This is 1 byte. This one, you need to put another one, 1 byte. And this one is another 1 byte. All together you need to have 4 byte. Why? Because EAX is 32 bits. So how you going to restore it? You're going to store it using this. If your answer is 10000H, it's going to be wrong because this is only 1, 2 byte 1 bits, baby. So that is not enough space. So you need to occupy all. So for hexadecimal, I repeat again, these 2 digit equal to 1 byte. Byte ya, not bits. This another 2 digit is another 1 byte. Okay, so this is 1 byte, 1 byte, 1 byte, 1 byte. Please make sure it is hexadecimal. If it is a decimal number, let's say I have move AX 10,000. 10,000, I cannot put EAX equal to 0.0010000. This is wrong because this is decimal. For those that I want to put it here, it is should be in hexadecimal. So I need to convert 10,000 decimal to hexadecimal first. You use your scientific calculator and you find out what is the value inside your hexadecimal. Then you put it, and please make sure that you occupy 4 bytes. So next is you add 40,000 hexadecimal, then you're going to will get 50000 hexadecimal, but you need to put another zero also because this is 1 byte, 1 byte, 1 byte, 1 byte, 4 bytes altogether equal to 32 bits. And then you subtract, you will get the value, final value. So now, after you run, you're going to see like this. If you use the dump register, so your EAX will be look like this. Okay, it's not going to put H, but you will know that in your register all is in hexadecimal value. Okay, let me try to run this command. Source code. Mana dia tadi? This one, right? This one. Okay. Okay. So you can see over here what I need to do first. I need to review. So when I review, I can see. I think starting from this, I get
In
error. What
the
happened?
last line, you just missed the last line.
Isn't
End,
it?
end main. Yeah,
Oh,
yeah.
okay. Uh, okay. Now, after I click view review, so I can see that one success, no fail, no skip. So there is no error, there is no warning. So now I'm going to try to debug. So you can see over here, this is basically similar to the output. Okay, this one. Your EAX. Okay, the value of your EAX is similar. So ignore the rest because as I mentioned, it's by default sometimes it's changing. EAX is 000300000. It's similar to the answer, and it is all 4 bytes. Means 32 bits for this EAX register. Okay. Later on, you will learn what is CF, carry flag, sun flag, zero flag, and all extra. Okay. Okay, now we move to another. Okay, before that, I will also show you. Let's say I have this one. I can also use step over. So this one under step over, you can see that where are you? You're going to debug each one by one. See, I do another step over, but you can also use your F10. So when I step over it, you can see that I use the F10. So it is now until here. So maybe from here until this one, where is my, okay, until this one. Let me try to do it to see what is basically happened to my register. Okay, now my register currently, if you can see, it is just 00100 because I just finished this line and I'm going to move to here. So I move another one, okay? I step over another one time. Aduh. So I move another one time. Wait. Okay. Now I until here only, but I didn't execute yet. But I already execute these two line. So let me see. This is the window for my register. Now my register of EAX is 005000 because I already execute at 40,000. So see, it's changing when I move it. So this is how you're going to see line by line when you want to check what is has actually happened. Okay, so you can play around. Oh, no, 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 no. Okay, you can play around with all this one because in your lab also you need to show it all the window, register your memory, uh, watch. Another one I forgot. Uh, so I already show you how to use it, and now we will continue. Okay, this is write the following okay. This one is similar. You just copy paste. So now we're going to move to defining data. So you have several, not just several, it's a lot. You can see that you have index data type. What is that sound? Or maybe it is Facebook. Okay. Oh, you have the intrinsic data type, you have data definition statement, little Indian order. This is how you're going to learn, you're going to store your data. So you use this method. So define byte, sign byte, word, sign words, D word, and etc. Okay, we're going to jump it directly. So under our intrinsic data type, so each intrinsic data type describes a set of value that can be assigned to variable and expressed of the given type. So let's say the essential character of each type, it is in sign of 8 bits, 16 bit, 32 bit, 48 bit, 64 bits, and 80 bits only. So only this size you can use for you to essential the character. So the assembler is not a case sensitive. So the directive just as the word can be also write in a small letter, capital letter, and so on. So this one you need to memorize. I think it is easy for you, not for you, hard for you to memorize it. But I already share it is 8-bit. But if there is a S over here, it will be sign. It will be sign byte. If word, it is a 16 bits. Or sign word, it is 16 sign integer. D word is 32 bits until finish. So you can see a word 16 to D words. Okay. So over here you can see before this I show you 1 byte equal to 8 bits. Okay, you have one word equal to 2 bytes. So if let's say you have one words, ya Allah, one word equal to 2 bytes equal to 8 times 8 times 2 equals 2 byte. So it will be 16 bits. For double word, it will be 4 byte equal to 8 times 4 equal to 32 bits. So each digit is occupy each 2 digit is occupy 1 byte. Same goes what I show you before this, like this one, right? So this is 1 byte, 1 byte, 1 byte, 1 byte. This is one word. If you combine it all together, it's going to be double word. Okay, I show you again. This is 1 byte. If you have 2, it's going to be 1 word. If you have 4, which is 2 words, 4 and 4 over here, 2 words all together, it's going to be double words. So this is equal to 32 bits. So go back to here. See, double word. It is a 32 bit. Sign double, it is 32 sign integer. F. Now you have F. F point in protected mode. So you have 48. Q. You have 64 bits. Means as a code, which is you have this 32 you times dengan 2. You ada quote of your words. Kalau words ni ada satu is 16. Quote ni selalunya 4, right? Time 4. So you times with 4, you will get 64. And lastly, your T, which is 10. So this is all mathematical term. So if you have problem with mathematics, then it's hard for you too. Banyaknya WhatsApp. Apa ni? Wait. Wait ah. Hmm. Okay, now you can see that you have data definition statement. Where is my pointer? Okay. A data definition statement. Set aside storage in a memory for the variables with a optional name. So in creates variables based on in strict data type. Okay, you can see the example. This is the standard. How you going to use the data definition standard? Count the words. So you have 1, 2, 3, 4, 5. This in decimal. You count, but you're going to apply it until the words, which is 64 bits. For number, you use pi, 63. Huruf pi, M. Nilai words. Okay. So this is how you're going to store your data using a little Indian order. So how? Let's say you have double words. This double is your identifier and this is your words and this is the value. Hexadecimal. Now using the little Indian order, you're going to pick this one byte, put it into this one. This another one byte, you will put it into this one. This one byte, sorry, until 3 only. Put here. And lastly, this one byte into this one. Because this is one word. Check back. One word equal to 2 bytes, which is 16 bits. So you have 1, 2, 3, 4. So this is one word. This is one word. So you have name of doubles. This is not the words, okay? This is word. So you have double words and you have this number and you put it all together in here. So you will occupy all of these similar also with words over here. 60 bit. So basically you're going to have 16 bit only. But because of let's say this is just example how you're going to put the order, then that's why you will put like this. Now later on I will show you the example. Okay. This is example 1. Let's say I have my data D words. D word is 32 bits. I have this value. Alamak, I forgot what is the answer. Maybe someone wait, I check it, convert it into hexadecimal. So I make the table first. 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 2, 3, 4, 5. Okay, this one is 6. 1, 2, 3, 4, 5, 6. I have the value of 3740. Can you change it into hexadecimal? In hexadecimal, it's going to be 0, 0, 3, 9, 1, 3, D, 1, D. Okay, someone, please ask me what is the value of hexadecimal. I will pick someone. MD Mahidi Hassan. What is the value in hexadecimal? MD Mahidi Hassan. MD Mahidi Hassan. What is the value for hexadecimal? Hmm.
Hello.
Yes. What is the answer?
Value means the base.
Convert from decimal to hexadecimal.
Can I have the question, ma'am?
What are you
Because
doing?
actually I'll join late.
No, it is not about the late. I asked you direct question. Now, change this decimal to hexadecimal.
Okay. Give me 1 second.
Wait, I want to check. How to... Okay. MD. Okay, Saurash Ahmed. What is the answer? Saurash Ahmed. I can just copy paste the number and put it into my Google. There is a lot of converter, but if you have scientific calculator, you can just direct convert it. It is not tricky question at all. Saurash Ahmed, are you here? No, so I remove you from this meeting.
Can you tell the number again, ma'am?
The number.
I mean in comment section.
This is the number 3740625.
Its hexadecimal number is 3913D1. Am I right?
Again? 3913D1. Okay. Yes.
3913. Yeah, D1.
So that's correct. So the value you need to put in how to make it. Okay, wait. Over here, you need to put it the value. This one, if you direct convert to hexadecimal, you're going to be 39130D1 hexa. So you can see if you first pick this one, you're going to put D1, and then another one is 13, and this one is 39. So this is one word, and then this is another one word, because you need double. So that's why you need to put 00 as to occupy it with a double word. So next, you have two DUP. Later on, you will learn DUP is duplicate this value. This one is already direct give you in hexadecimal. So I will take 0E, and then CD. After that, AB. Then I have 2. I cannot just put it as 2. I need to put it as a 0. 02. So I occupy. This is one word. This is one word enough as a double word. Then I will duplicate everything. So I duplicate starting from 0E, CD, AB, 02. So this is the answer for this one, this command line. So this is only one single line. If you have multiple single line, you don't know the basic, it's hard for you later on. So next, you're going to have exercise 3.2. Because I want to see the tables. So I'm going to pick percent again. What is the value of B? Ashraful Islam. What is the value of B? But you can see the B is, there is something, it is not hexadecimal, but it is ASCII. Mana orangnya? Siapa tadi? Siapa yang sebut tadi? Ashraful Islam. Are
Yes,
you
ma'am.
here? What is the answer?
Let me try. Wait a minute.
Okay. So I already give you a hint that this is, Allah, this is not hexadecimal. This is ASCII. Because if you go back to your previous note, this is the ASCII character. So this is ASCII character. You need to convert it into hexadecimal.
Yeah, it's 42, I think. Yeah.
Okay, so you can just find out the table for ASCII, or maybe you go to your Google. Basically, this one is already if the question asks you, so it will give you a table, because it's hard for you to memorize, right? The table for ASCII to decimal, ASCII to hexadecimal. So I'm going to write the answer. Okay, first, words. So one words only, these two, right? So these two is one word. So first of all, I have 4F hexadecimal. I put it here 4F. But it is not yet one word. So I need to put 0, 0 to be one word. After that, I see, oh, there is a duplicate 2 times. So I need to duplicate 4F 0, 0. After that, I already duplicate it. I go to next. This one is undefined character, but it is one word. So it will be something over here which is undefined. So I put it empty because I don't know basically what is this. And this is the symbol for undefined, which is I make it as empty. So it need to be one word also because it is a word, not a double word. Then this one, B in ASCII is going to be 42 hexadecimal. So 42 hexadecimal, I put 42. And this one is not yet one word. I need to put 0, 0. After that, I have this one. 25. Wait. I have another one which is 25. This one, I will convert it into hexadecimal. It is 19. So 19 over here, it is 0, 0 because it is one word. And that's why I put in front like this. Okay. Same goes to for F, H, I need to put 0, 0. So lastly, this number. Oh, sorry, this number. So I have 500DH. So this one is 0D and this is 50. So this is one word. So this is how basically you store into your storage. You have part by part. Let's say for 2 words over here, it is 32 byte. Maybe it is register EAX. So you store all this number. Maybe this EABX. You store this number into your register. So you need to know how you register. So this one maybe you can try. What is the answer? If you did not run it also, basically you can get the answer by just looking at it. AX. Okay, first you have 0. And then AX, you have CTH. Look into here, CTH, you have 34. It is a byte. So byte is 34. It's okay. Then you have another one. You need to move to your BX. So now your AX is 0, 0, let's say. And then your AH is CTH 34. Then after that you have BH 0. You have VH val plus 1. So this one you plus with 1. You cannot just simply add because this one is hexadecimal. You need to add with 1. So what is the answer in hexadecimal? So please try to do it manually. You look into one by one the paragraph. And maybe you can also try to run it using your Visual Studio. So next is under defining the bytes and sign bytes. So over here you have example value, which is byte. This one is character constant. And you have another byte, which is the smallest identifier byte. And then you have the largest unsigned byte. This is the value. You have unsigned byte, the smallest signed byte, the largest signed byte, and also this one we already looked, which is unidentified. If it is byte, then it's byte. If this is a word, it's unidentified words. So maybe you can see over here. Okay, from here. Okay, sequence bytes in memory. So first of all, you have byte, this one. So basically, you need to change it into hexadecimal, but this is just for you to see how you put into your storage. So this one you need to change it into hexadecimal. So that's why it put like this, because this one is not the hexadecimal number. So this one unidentified, you're going to put it as empty also. So multiplier identify. So you can see that if multiples initial sorry, multiple initializer. So if you have the multiple initializer used in the same data definitions, it is a label refer only to offset of the first initializer. So the example, list 1. So you have list 1 with a byte 10, 20, 30. So you put 10. This one is decimal, but you need to convert it later on to hexadecimal. If you convert it off, you will get A, right? A, so 0A. And then this one 20. And then 30. After that, another one. So this is dalam binary. This is in binary, but you need to convert it basically for your Visual Studio, and also your answer, it should be in hexadecimal. Next is this and this one. So this is just to show you if you have multiple identifier. This one, you have one, but you identify it using this paragraph, and you have another identifier, and you put it all inside this. Next is defining strings. So to define string character, enclose them in single or double quotation mark. So this one is double quotations, and this one is single quotation. And also normally in command, you're going to end with a 0 at the end of your string. So basically you can also write it in several ways. So you can have good morning, good afternoon, good evening, but normally it's going to have the 0 at the end of the character. This is also another example, but you can see this value, these two, already assigned to be as a carry return and line fit. So if you put over here like this, it is not a value of H or hexadecimal. Maybe you mistaken up OD, you will store inside your AX. OAH, you will store OA inside your register of storage. No, it is already stated for OAD is already fixed to be carry return, and also the line fit. So please don't mistaken it. So next you have DUP. This one you already look like you need to multiply it using, let's say over here you have 20. So you're going to multiple it using 20 times. If you have 0, so you're going to have 20 0. If you have this undefined, you have 20 bytes of undefined. If you have 3, you're going to have 3 COA, COA, COA. You can see COA, COA, COA. So you have altogether 9 bytes. And then you have tens. You can see over here you have first you have 0. You duplicate it with 2 times. This one is your decimal. You convert it into hexadecimal. And then you have 0, 0, which is 2 times. And lastly, your hexadecimal, 20, you convert it into hexadecimal, you will get 14. And defining word and sign word data. The words defined words and assigned words defined as assigned words. So this directive creates storage for one or more 16 bits, which is 2 byte integer, but it also will depend on this. If it's word, it is 16. Sign word also 16, but it is a sign 16 bits. Same goes, this one is all 16 bits. And this is the example. If you convert it directly to hexadecimal, what you will get. First of all, you have this double word. So you will put, first you will tag this, right? Put it here. This one is 000, and then this is 0001, 0002, 0003. Basically, it's similar. If you draw it like this also can. And then after that you have 004, 0005, 0006, 0007. Altogether you have 6. Okay, now 6 plus 8. Sorry. So you have a double word. One word, 2 bytes, right? Like this. So you have double, you have 4 bytes. So here you will put this, and then 56, 34, and then 12. All is one words. Sorry, what double words. So all this is double word. Then after that you go to the second line. So you have sign double word. This one you need to change it into hexadecimal because it is in the decimal. So in hexadecimal it's going to be like this. So you will put 00 first, and then 0000. Lastly, you add 0 using the little Indian methods. Now you have defining keywords T by you can see this is called words, which is kali 4, which is 4 times from your words. And your T bytes, it is 10 bytes packet. T refer to tens. So you have like this keyword, you have long like this, but you need to calculate whenever you store. You will get 32 bits of 4 words. If it is not enough, you need to put 00 in front. Same goes to your T words. It needs to be 10 bytes. If it's not enough, then you need to add it. And your another one is also this one, T bytes, this one. So you need to convert it into hexadecimal first. But maybe if you try to convert it, is it invalid or not? Please try to convert it. Next, you have the defining real number data. What pages? 56. A lot to go. Okay, real number data. You can see over here you have real 4, real 8, real 10s. So 4 byte single precision, 8 byte double precision, 10 byte double extended precisions. So you just extend it to be real 10. So this one is val 1, real 4. You have minus 1.2 and then 3.2e. This one is just how you represent it. And this is the standard for real number type. So you have the range. Please remember the range also. For short real, how many digits? Long real, how many digits? Extended precision real, how many digits? And also the range. Over here is addition variable to add sub program. So using add sum.asm, this one, the previous template, we can add data segment. Okay, this is the value. So what you need to do is you just copy all these and you put it into your Visual Studio, and then you can try to rebuild and you try to uh, debugs it. So maybe after that you can see what is basically the value of EAX. Betul ke tidak? So now your EAX is 0.0030000. So this is the value. So maybe you can try it because it is already include different. And maybe also you can try to write it using step by step. Using step over, and then you do it another step over until line by line, and you check your answer using this window under your register. So you will check. First of all, there is no value, which is the value of EAX. After that, what will happen when you move, when you step over again? What will happen? Now you see your value is already applied 10,000 H. After that, you try to step over again. After this, what will happen? And so on. Please try to do and play around with your Visual Studio. So we're going to go to another subtopic, which is the last subtopic under our module 3. You can see that we're going to look into the overview, equal sign, and also EQU directive. A symbol's constant or a symbol definitions is created by associate identifier, which is a symbol. You can see that with an integer expression or some text, symbol do not reserve storage. Is it symbol use storage? No. The value change runtime? No. So your symbol did not affect your storage and also any changes in a runtime. Only variables can be stored in your storage and also change using your runtime. So your equal sign directive, you can see you have the name, it is equivalent to expression. So maybe you can put count equal to 5. Maybe also you can put data equal to 100. Any time, any name. You just use the symbols of equal just to express it using the equals. Then if you look into this example, count equal to 5 and then move. This one is your accumulator low register. So count store in your accumulator low. So the value of your accumulator low is equal to 5. EQU directive. You can like name EQU expression or maybe symbol or maybe a text. So this is an example. Press key EQU. Press something, then you print out this one. So I copy this and then you can see what is the output. Okay, sorry. Okay, if you can see over here, it's similar to your output, which is you need to have write your name here. Write your name here, press any key to continue. Of course, this is the output, which is my name EQU, write your name here. If you know C programming, maybe it is similar to printf. Basically, this is you state this my name equivalent to your write your name here. So this one will be pointing out to your output, and then you can just print anything. Oops. So this is the example. And okay, you already finished all. So before we finish, I'm going to try to open the lab 1. Wait, because I want to show you how you need to do. Where's the lab 1? Okay. Entire screen. Okay, this is your lab 1. This is how it look like. You're going to see that you have this kind of template. What you need to do is you need to fill in everything, and over here you can see simple program to familiarize blah 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 blah. So please execute. The program is already given. What you need to do is you just copy and then you paste it into your VB. Of course, maybe you can just rename it lab 1, lab 2, depend on the question. Also lab 1 part A. So you save it using your name. And over here, I already paste it. What you need to do is you need to do review and start without debugging. So you need to record it. No need for you to record starting from copy and then you paste. So it's going to take long. What you need to do is you paste it first and then you start record like this. Okay, now already here. Start record and then click review. And you show, okay, this one, there is no error, it's already success. So maybe you can just add your voice in, so I know that different person are uh doing it. Maybe if you just recording it, maybe you can pass with your friend. So I don't know whether you are the one that do or others do it for you. And then after you already review, then you click start without debugging. So you show it. Okay, this is the answer. Uh, the EAX is 0003000, and then you stop your video. That's first that you need to do. Second, if you scroll to your lab, this one is similar also. What you need to do is you just copy paste and then you record that. But after that, you can see detail debug process. What you need to do? You need to show 4 window: watch, autos, memory, and register. So you need to you have one part A, part B, part C. So you can also do it in a video, but you need to also screenshot so that I see it like this. This is memory, this is watch, where is and then there is a register window. You screenshot and put it into the part part A, part B, and then part C. So I show you how to do. So let's say this is your part A. What you need to do is you need to click on step over first or press your F10. So when you press your F10, okay, mine is by default open and others. I put it here. Okay, step over. If you, okay, I show you why. What happened if you did not uh if you do not click the step over? What will happen is there is no window for your register, there is no window for your watch. What else you need? Watch, autos, there is no window. This one you can see over here, debug window, there is no listed here, right? So you need to click step over first. When you already step over, you click at debug window. Now you see it all. Register, you have one window. Maybe you can make it nicer like this. Too big. Maybe I put like this. Okay. Then I put here and I screenshot my register. Maybe I put here. Okay. And then another one. Debug window, memory. Pick another memory. So I put it, maybe I put it here. So I smaller. It depends on you how you're going to do. Okay, like this maybe. And what else? Window, autos. So I put autos here maybe. And then another one is apa lupa, watch watch rasanya. So I put it watch. And then auto. Oh, sebelah-sebelah. So maybe I have like this because we need to have 4. Watch, auto, memory, and register. So I have 4 like this. And this is my part A. So I have this, I screenshot, I show and I paste it into my part A. So this is for my part A. So is it okay or not? So I already show you all the step. Hope that you know how to do it. So this one is under your step over. Then it's going to come out. If you did not click the step over, then you cannot see the the what the link for you to open all the window. So only that. Everything already started here and you just need to copy paste. The objective of this lab 1 is only for you to get familiar how you're going to run, how you're going to debug, what you're going to do with your step over, how about the window and everything. So you need to score this lab because this is the easiest lab. And after this, I will create a link in your e-learning for you to submit the lab 1. So I will give you 1 week. So you have another maybe 30 minutes. You can try to do it. And tomorrow you have the class, right? For you to do asynchronous. So please try to finish the lab and submit it before the due date. Is it okay? So next week we're going to jump to our module 4. So any question? So if you did not understand or you forgot, you can just repeat and play back the video. I will put it into your e-learning, especially for the lab 1. Okay.
Doctor, is test
Yes.
one getting checked by e-learning?
Yes. Why?
How are calculations getting checked by e-learning?
Because you put directly the answer into the specific uh, point, right? The step 1, there is a table, then you need to key in inside that. So we already assign specific answer. If you put the same answer, exactly same, let's say 0, 0, 0, 0, then you correct. If you have wrong in 1, 0, 0, 1, let's say, you're going to get wrong. Of course, maybe also same. Let's say you know basically the answer is 0, 0, 0, 0. That is 40, but you by mistake there is a space 0 space 0, 0. It also will be considered as wrong. That is the disadvantages using the cloze test using e-learning. Maybe you know the step, right? But when you key in it's wrongly, then it certainly will get wrong. Okay, so that's why I also told other lecturer, I said we want to know the understanding of the student. If we let the e-learning to marking, so maybe the student know how to do. There is a step, but maybe it's just different. Like maybe step 1 it put step 2 answer. Step 3 you put step 4 answer. Different synchronization also you will get totally wrong, right? Then I think it's not very good. But I don't know, I need to follow the majority or the lecturer want to do that way.
So will there be a retest for the previous test?
Well, again?
So assuming that somehow the one that doesn't get the required score, will there be a retest for the previous test?
Uh, I I don't know yet because the other lecturer didn't discuss about this. But basically, if you have 2 low marks, normally other subject will do retest. But I don't know this time. But I hope you need to do this test because if I check, the mark is too low. It's too low for especially for MGIT student. So that's why I said, what happened? Because we already done too many exercise together, but seems like you cannot apply it, implement what we have learned.
When we can see the result.
Basically, now you can see the result, but due to I still try to sort off, because if you check, there is more than 400 students upcoming all together in. We forgot to separate it. Should be you need to click your specific section. Then your marks will be divided into specific section. Now everything was messed in one section. So now one of the lecturer are trying to divide it using specific section first. Then I can see. But if you want me to check, you can just WhatsApp me and ask me to show your marks.
Okay, thank you so much.
Okay. So any other question?
Can you show us the QR code at the end?
Okay, wait.
Yes, doctor.